Direct collapse black hole discovery in infinity galaxy. Astounding discovery. Recent examinations of archival data from the James Webb Space Telescope have uncovered a cosmic event that could reshape our understanding of black hole formation. On July 15, 2025, researchers poring over the JWST archives identified a rare instance where two colliding ring galaxies appear to have merged so forcefully that they may have directly spawned a supermassive black hole within what is now referred to as the infinity galaxy. This candidate direct collapse black hole is thought to have emerged from the immense gravitational and shock interactions generated during the galaxy's dramatic encounter, process that challenges some conventional theories about how these enormous cosmic entities come into existence. But here's where it gets controversial. While many in the astrophysics community are excited by the possibility that such collisions can birth supermassive black holes in one swift collapse, others argue that alternative explanations might still be on the table. This intriguing observation, first reported on AAS Nova under the title, A Candidate Direct Collapse Black Hole in the Infinity Galaxy, not only highlights the dynamic and often violent processes that sculpt our universe, but also invites a spirited debate. What do you think? Could this be a groundbreaking clue that forces us to rethink the origins of supermassive black holes? Or is it merely an anomaly waiting for further evidence? Share your perspective and join the conversation on this fascinating topic. Has the JWST discovered the first direct collapse black hole? Hold on to your telescopes. We might be witnessing the birth of a cosmic monster for the very first time. The James Webb Space Telescope, JWST, could have spotted a hypothetical type of black hole that defies everything we thought we knew about how these giants form. For decades, astrophysicists have struggled to explain how supermassive black holes, colossal objects with masses millions or billions times greater than our Sun, appeared so early in cosmic history. The leading solution: a controversial idea called direct collapse black holes, which skip the usual stellar death process entirely and form straight from collapsing gas clouds. But here's the catch. Until now, nobody knew if these theoretical beasts actually existed. Enter the infinity galaxy, a cosmic crash site that just might hold the smoking gun evidence. But here's where it gets controversial. Could this discovery upend our fundamental understanding of black hole evolution? Let's dive in. In newly released JWST observations from the Cosmos Webb survey, which maps over 1 million galaxies across cosmic time, astronomers spotted something bizarre. Nicknamed the infinity galaxy because it resembles the infinity symbol, this object formed when two galaxies violently collided. That collision created ring-like structures around each galactic core. But here's the twist that left scientists baffled. A supermassive black hole wasn't anchored in either core, as expected. Instead, it floats right in the middle of the collision debris, surrounded by a vast sea of turbulent gas. And this is where things get truly groundbreaking. The research team, led by Yale's Peter Van Dokkum, proposes we are seeing a direct collapse black hole caught in the act of formation, something never observed before. Here's why this matters. Supermassive black holes shouldn't exist so early in cosmic history under conventional theories. There are two competing explanations. The light seeds model suggests they grew slowly from collapsed stars, weighing maybe 1,000 solar masses, through gradual mergers over billions of years. But JWST keeps finding gigantic black holes in the infant universe, too early for this slow process to work. The alternative heavy seeds theory proposes direct collapse black holes as a solution. Gas clouds collapse catastrophically into black holes, weighing up to 1 million solar masses instantly, no stars or mergers required. But here's the problem: gas loves forming stars when it collapses. How do you suppress star formation to get a black hole instead? That's the trillion-dollar question that makes this theory contentious. The infinity galaxy might hold the answer. Van Dokkum's team suggests that when the two galaxies collided, their gas compressed violently in the chaotic middle zone. Imagine two whirlpools slamming together. The shockwaves could have created such extreme density that the gas bypassed star formation entirely and collapsed straight into a black hole. Supporting evidence pours in. Chandra X-ray data shows the black hole actively feeding. Radio waves from the Very Large Array pinpoint it perfectly between the galactic cores. An ionized gas cocoons it like a cosmic nursery. And this is the kicker. New JWST measurements show the black hole's velocity matches the surrounding gas perfectly, strongly implying it formed right there in the collision aftermath. But wait, there's a plot twist. Additional JWST observations revealed two more supermassive black holes, one in each galactic core. While this complicates the picture, it doesn't weaken the central mystery. The middle black hole's location remains a profound oddity. Van Dokkum acknowledges alternatives. Maybe it's a runaway black hole ejected from a galaxy, though its matching velocity argues against this. Or it belongs to an unseen dwarf galaxy. But dwarfs don't host such monsters. These possibilities aren't fully ruled out yet. Now, here's where you come in. What's your take on this cosmic detective story? Do you buy the direct collapse hypothesis, or is there a simpler explanation we are missing? Consider this: if gas can collapse directly into black holes under extreme conditions, does that mean the universe creates monsters more easily than we ever imagined? Or is this just an exotic outlier? The implications could rewrite astrophysics textbooks, so what do you think? Defend your stance in the comments. Rare direct collapse black hole found by James Webb Telescope. Astronomers have made a groundbreaking discovery regarding the formation of black holes. Utilizing data from NASA's James Webb Space Telescope, two researchers identified a unique scenario where a supermassive black hole emerged in an unexpected manner. The discovery involved a pair of spiral galaxies colliding in space, each containing a black hole, at its center emitting a red glow. Surprisingly, a third supermassive black hole, much larger than the others, was found in the space between the galaxies. This peculiar formation, dubbed the infinity galaxy, challenges conventional theories of black hole formation. The researchers proposed two theories to explain this phenomenon: the light seed scenario involving the gradual merger of black holes, and the heavy seed scenario where a supermassive black hole forms directly from a gas cloud collapse during a galactic collision. The latter theory, supported by observations from NASA's Chandra X-ray Observatory and the Very Large Array, suggests a direct collapse black hole formation. While alternative explanations exist, the researchers believe their findings provide compelling evidence for a unique black hole formation process. This discovery sheds light on the complex and diverse mechanisms involved in the creation of black holes, pushing the boundaries of our understanding of the universe.